welcome. This is Obi Science Lab, and we discuss science and mathematics. We break down the principles and the laws guiding this special field for better comprehension for students in this area. Today we'll have a question, and the question says, from the equation above, calculate the volume of unreacted oxygen gas if a mixture of 50 cm3 of hydrogen and 75 cm3 of oxygen are involved. So the question is asking us to calculate the volume of unreacted oxygen gas. The volume of unreacted oxygen gas. So this is the equation of reaction. We have 2 moles of hydrogen gas reacting with 2 moles of hydrogen gas reacting with 1 mole of oxygen gas, giving us 2 moles of steam, gaseous water. So, looking at this question, this is drawing our attention to Gay-Lussac's law, which says that the number of moles of this, this is 2:1:2. Their number of moles are directly proportional to their volume. So what it's saying is that the old law is saying that these moles that we have here are in direct relationship with their volumes. So and the question is telling us that 50 cm3 of hydrogen and 75 cm3 of oxygen are involved. So before this reaction, before the completion of the reaction, what we'll have is 50 cm3 of hydrogen, 50 cm3 involved, oxygen 75 cm3 involved. No product here, that is before the reaction. But after the reaction, the whole of the 50 cm3 of hydrogen will be used up. But what quantity or what volume of this 75 will you take? The simplest way to go about this is by dividing your 50 by 2. 50 divided by 2 will give us 25. That simply means that you have 1 mole. It means that 1 mole can take 25 cm3 in this particular version. When you have 2 moles, that 2 moles can take 25 times 2, which is 50. So 2 moles will take 50 cm3, while 75 will take half, which is 1 mole, which is represents 25 cm3. So half of 50 is 25. So this can take 25 cm3 after the reaction. The maximum volume it can take of oxygen is 25 cm3. But what was supplied is 75. If it takes 25, what will be left will be 75 minus 25, which will give us equal to 50 cm3. The product also be 2 moles representing 2 times 25, which is 50 cm3. That means the volume of oxygen that is unreacted, or the leftover, or the remainder from the volume of oxygen that was provided, will be 50 cm3, because 25 will be taken out of the 75 provided, and 50 will be left of oxygen. Therefore, 50 cm3 of oxygen gas will be left after the reaction. From the options that we have, B is the correct answer. 50 cm3 of oxygen. The volume of unreacted oxygen gas is 50 cm3.